Hi, dear students. This is Harita Kasturi from PACE IIT and Medical, Hyderabad. So let's go with yet another interesting chapter, reaction mechanisms, which is a part of your GOC, which deals with how do the reaction proceeds? What kind of products are we going to get? Are we going to get the stable products, unstable, which reacts with what to give, what compounds? All these kind of mechanism-oriented things deals with reaction mechanisms. So for that, we need to very importantly, the very utmost important thing what we have to go up with is the priority order of the carbocations. Carbocations is carbon के ऊपर positive charge. It is carbocation. And the carbocation will be stabilized if it is a cyclopropyl carbocation. Then you have a 3 degree, then benzyl, allyl, then 2 degree, 1 degree, and methyl. Benzyl and allyl, because of resonance, they are stabilized. 3 degree is definitely you have 3 carbons to support the positive carbon, thereby tending those electrons towards. So therefore 3 degrees better carbocation. Cyclopropyl is the most because you have 3 things in the cycle which is donating the part to it. So cyclopropyl is the most better. Then 3 degree, then benzyl, allyl, 2 degree, 1 degree methyl. Similarly, if you have to go with your carbon free radical is I have one unpaired electron with me ready to mingle with another electron. So unpaired electron with another electron. So to pair up the electrons and all, we use this carbon free radical mechanisms whenever we see there. Benzyl is the most stable, then allyl, then 3 degree, 2 degree, and 1 degree, then methyl, right? Then you have carbanions. Carbanions is carbon के ऊपर negative charge, that would be benzyl, allyl, then methyl, then 1 degree, 2 degree, and 3 degree, because you should not have more of a support. If you have a negative, like if you have carbon with a negative charge, and if you have three carbons groups supporting this, so carbon is always a helping group, it's always a giving group generally. So when carbon gives in, thereby increasing this negative charge a lot, thereby unstabilizing this compound. So 3 degree carbanion is the least stabilizer thing. All right. So depending on these things, I think we can now go up with our questions based on this. So the very first question from your exercise coming up is consider the following carbocations. Now, always you have to check up whenever you are given a carbocation, which carbocation is that? That is 1 degree here. And this is what? Allyl or vinyl? This is vinyl, the most unstable. Vinyls are unstable. Vinyl matlab kya? What do you mean by vinyl? Vinyl is double bonded carbon ke upar if you have a charge, that is called as vinyl. And double bonded carbon ke next carbon pe when you have a charge, that is allyl carbons. And allyl carbons are more stable carbocations, I would say. Then you have benzyl. Benzyl is even more stable. So 4 is stable. Then you have 3 allyl. Then you have out of 1 degree and your vinyl definitely 1 degree. So 1, and then your vinyl is the least. So option A is my answer there, right? Next, the compound which gives the most stable carbonium ion on dehydration. Whenever we are talking about dehydration, we need to remove water molecule. So water molecule gets removed only when OH minus ions can come out along with the H plus and all. So first we need to talk about the OH minus ions coming out. Butan 2-ol, always draw butan 2-ol, 4 carbons with OL here, and 2-methyl propan 2-ol. The second one is 1, 2, 3 propan 2-ol is second position all, and on the top, which is 1 methyl group, so 1 carbon group on the top, and then you have butan 1-ol, 1, 2, 3, 4 with OH group, and then 2-methyl propan 1-ol, 1, 2, 3 propan 1-ol, and 2-methyl. Second position you have methyl, and then first position you have alcohol. Now, whenever you see these things, like you need to first undergo this thing. So OH is coming out. So this carbon is under risk. That carbon attains the positive charge. The second carbon here attains the positive charge. And here in this case, OH comes out. This carbon at a risk. this carbon attains a positive charge, that is 3 degree carbon. In the first case, 2 degree carbon is attaining a positive charge. Second case, 3 degree. Third case, OH is moving out. So this is attaining a positive. This is 1 degree. Shifts happen, that is different. But now, apart from without the shifts, what exactly is the carbocations formed? I'm just checking out. And here, this is moving out, and this carbon is directly attached to one carbon, which is 1 degree here. Then the compound that will give most stable carbonium ion on dehydration. The most stable, I would say option B. Option B, it is 3 degree, right? So option B is my answer there. So second option will be you're taking up a lot of this because it is your 3 degree thing. And then if you have to talk about, then you can talk about the 2 degree there. 2 degree here, direct 2 degree is your option A. And then this carbons can be made like, option D, check karo of option D, the positive charge on this can be shifted by undergoing a hydride shift. So carbon to carbon, this is the carbon, this becomes your positive charge. So thereby, this is a 3 degree shift going on. So therefore, first option is second option. Then you have fourth option. Then you have what? Then you will check up with your 2 degrees. So actual 2 degree is option 1. So and then your 3. Third option can be made 2 degree by undergoing a shift, which is your hydride shift. All right. So that would be order for your question number 2 in case order is being asked to you. But here in this question, it's only which is the most stable pucha, so option 2, because it is 3 degree. 3 degree is the most stable. 3 degree carbocation is the most stable one. Next, move on. Allenes give electrophilic addition in the presence of polar protic solvents. Yes, polar protic solvents. Whenever you have protic solvents, you have H plus in that set. Okay, so polar protic solvents with those reagents which on dissociation give electrophiles and nucleophiles. Yes, which reagent will not give the addition reactions? It says here it is H plus Cl minus, H plus and HSO4 minus, HOH minus and Cl plus. Remember, if you have OH and Cl, OH minus and Cl plus, then Na plus Cl minus. So option D is my answer there because that is aprotic. We don't have any, this is not even a solvent here. Which reagent will not give addition reactions? Na plus Cl minus cannot give unless you have a solvent, you will not get it there, right? Next, which of the following carbocation is the most stable? Most stable again, carbocation, this is 2 degree, this is 3 degree. 3 degree undoubtedly the most stable. Okay, then you have this carbon is attached to the carbon, double bonded carbon. This is my allyl group, allyl. So that is also one thing what we have to talk about. And then we have this carbon pay positive charge, and this is 1 degree only. So 3 degree is the most stable. 3 degree, then benzyl, then allyl, then 2 degree, then 1 degree. So option B first, then C. We don't have benzyl here, we have allyl groups here. So then C, then 2 degree, which is option A, and then D. Yes, 1 degree. The option D can be made into 2 degree by making a hydride shift there. But without a shift, option A is already a 2 degree there. So in between A and D, my A would be my answer there, which is more stable there, right? So BCAD will be my order there. Next, moving on with the next question number 5 there. Which of the following is the most stable carbocation? So wherever is the cationic part, wherever is the positive charge, just identify that. So this is the dot which I am showing. So this dot is a 3 degree dot, and here this dot is a 1 degree, here this dot is a 3 degree, and here this dot is a 2 degree. So definitely I have cancelled out my B and C there. Now option is between A and D. In between A and D, I can see resonance, which means charge, negative charge, single bond, double bond, and then single bond. I can see this set of resonance going on in option A. So A is more stable, then comes with D. Then I will talk about C and B if I have to put them in order, 2 degree and 1 degree, right? So that is how it is. Next, moving on, which of the following carbocation is most stable? See, everything is the positive charge. All here, all the top ones are CH2 with a positive. Now we need to check up which positive charge can be neutralized, which is most stable. Stability, which means I should not have accumulation of the charges there. I need to reduce my charge. Carbocation, if it has to be reduced on its charges, you should have some group which is inductive group or mesomeric group, which is withdrawing this positive charge, which means which is pushing the electrons towards it. Chlorine can do both the ways. Chlorine has got lone pairs on it, directly attach it to the group which is showing plus M effect also, and also it is withdrawing, so minus I effect also. So therefore, in the case of chlorine, I would say plus M and minus I both are there. Inductive will win the argument. Rest all questions, rest all cases, you will have your mesomeric effect winning the argument. But in the case of chlorine, chlorine has a withdrawing power, more of a withdrawing nature. Chlorine will be withdrawing. So I minus is doing the job. So here option A, you're getting in, also your electron is moving out. NO2, do you see this NO2 structure here? NO2, this should be the NO2 structure. Always remember, whenever you see NO2 there, you should see this. Okay, then you have your phenyl group there, and then benzene group there, then CH2 with a positive. So here N, nitrogen, is a positive, withdraws the electron. So as it withdraws the electron towards, thereby increasing the positive charge. B increases the positive charge, right? Because it is withdrawing group. And then option C पे भी देखो, oxygen is a giving group. Oxygen is a lone paired element, directly attached to the ring, will donate the pair of electrons into the ring. Thereby it is giving the electrons, therefore it can reduce the positive charge. And then D कुछ तो नहीं करेगा, which means I have C better. Okay. And then I have giving and taking, which is my chlorine, option A. Then nitro group is withdrawing group, thereby increasing the charge, positive charge of B to the most extent. So B is सबसे least stable. And D, कुछ नहीं कर रहा है, कुछ मत करो, काम मत बिगाड़ो. Remember this part. Okay. It is not doing anything. Option D is fine. So it's not doing anything. Neither it is increasing the charge nor decreasing the charge, which is fine then, right? So this should be the order you need to talk about, right? Next, in the benzene intermediate, the triple bond consists of what? So this is a very special case of benzene, wherein it is an intermediate. You have an ine part there. Do you see this part? So this is an ine part, and this is that partial double bond, triple bond that comes up because of the overlapping of sp2 bonds. So one sp2 sigma bond, one sp2 pi bond, and one p pi bonds. Okay, so option D, this is a very special case of benzene ring. Bacha, please write this down separately. All right, and these are the questions that will come up, and that is past paper questions. These are all right. So please be very careful. This is a very special case of benzene, right? And then the stability of a free radical, allyl, benzyl, all these things. Free radical bolte hi number one is benzyl, then allyl. Then you have 3 degree, 2 degree, 1 degree. Benzyl, allyl, then 3 degree, 2 degree, and 1 degree, and then your methyl group. Next, arrange the compounds in the decreasing order of heterolytic bond dissociation energies. So everywhere we need to talk about carbon to chlorine bond dissociation, which means chlorine takes the electron and moves away. Thereby carbon attains a positive charge. Chlorine is taking the electron and moving away, carbon attaining a positive charge. Now, who can stabilize this positive charge? Which means who can reduce this positive charge? That is the best, I would say, right? First option, कुछ नहीं कर रहा है. Oxygen. Now, the top group, whichever the group we are talking about, the main group is an electron withdrawing group because carbon is attaining a positive one. If carbon attains a positive one, electron will be moving out, which means whenever there is an electron moving out of your ring, your meta position is activated. Remember that. So meta position. So whenever you have the benzene ring and this group is the activated group there, there, and if that is withdrawing the electron outward, then meta position activates. This is ortho, meta, and para positions adjacently placed. Meta positions get activated, so oxygen donates the electron, thereby electron is taken here, and then the electron is being pushed to the part, right? And that is how this happens. So meta is the first answer. So option 3. Then you can go. Then you just have a very adjacent oxygen there going up with this part here, so therefore you can go with 1 and then 2 and then 4. 1 kuch bhi nahi kar raha hai, right? So that is better there. So option 3 better. Then you will go with 1, then 2 and 4, right? So 4 is your para position. So that would be option B there. All right. Moving on, which is the most stable carbocation? Stable carbocation. So do you see this part? Carbon, you have CH3 twice, so one hydrogen and then CH3 twice. CH3 twice, and iske upar positive charge. This will be my 2-degree carbocation, and this is benzyl carbocation. Option B is benzyl carbocation. Option D is a 3-degree carbocation. This is my 3-degree carbocation, and this is my allyl carbocation. So carbocations 3-degree is the best. So option D first, then benzyl, then allyl, then your 2-degree. All right. So then your A, D, B, C, A is my answer here. All right. Next, moving on. The rate of reaction of AgNO3 will be. So AgNO3 will be precipitated out as AgCl. AgCl will be precipitated there. So what will be your answer there? Which one, which chlorine will come out faster? That's what the question says. So oxygen is dumping in its electrons here. So thereby you can see a positive charge here, and the electron will be coming up to the chlorine, and chlorine breaks down easily. So 3 first. 3 is the first thing to go out. Okay, so 3 is the first thing, and then you have options 3. I know 3 option you have in both the cases because of the resonance. Option 3 here, like third position, chlorine comes out very easily because of the resonance. Then you have option 1 and 2, which can be more easy. I would say option 1, because this carbon, as the chlorine moves out, this carbon is a 3-degree one, and as this moves out, this carbon is a 2-degree one. So then 3-degree, then 2-degree. So 3 ke baad 1 and 2. So why 3 first? Although it is a 2-degree carbocation, it is having resonance. It is not, although it is 1-degree carbocation, it is having resonance stabilized structures. Therefore 3 is the most first, important, the first easily to go with. All right. Next, option B is your answer, the 3, 1, 2. Next, the correct order of reactivity of the following alcohols towards a concentrated zinc chloride. So alcohols, whenever you see these alcohols, first again, do the same thing. You will just bring out, this is positive, electron, take out positive, bring out the electrons from this positive. So now what is the groups that we are having there? This one, this carbon is my 2-degree carbocation with fluorine, and fluorine is a withdrawing group, electron withdrawing group, thereby increasing the charge density of positive here. That fluorine also, again here also fluorine, this carbon is again a 2-degree, but fluorine is a little farther from the position, and here this is a 2-degree carbon. Again, this is benzyl, this is benzyl carbocation. So benzyl carbocation will be more reactive, I would say, option 4. So bacha, you can always eliminate 2 questions very, very easily, because that's the beauty of organic chemistry, and then you will check up. So you are looking for the stability here. So stability ke hisab se 4th one is done, the benzyl carbocation, the best. Okay, because I don't have any 3-degree. If I have 3-degree, then 3-degree I would vote for, but I don't have 3-degree, therefore benzyl. Now out of these 2 degrees, which is better? Out of these 2 degrees, which one will be better is been asked. So here this is just a 2-degree there, but there in 1 and 2 options, 1 and 2, you have fluorine fluoro, which is withdrawing the electron towards it, thereby increasing the positive charge. When you are increasing your positive charge, you are not stable. So therefore option 3 there. So here also option 3. यहाँ तक तो सही है दोनों दोनों. Okay, option 3. Here also option 3. That is the same. Now 2 ज्यादा better है कि 1 ज्यादा. You have, see, option 1 में you have fluorine very closely attached. Closely attached will withdraw with a greater force. So option 1 is the least stabilized. Option C is my answer. Least stabilized, that would be my option C. All right, because as I can see there, I should not have charge accumulated on my compound. I should have a very much stable carbocation. The stable carbocation, as I can see, that would be my answer there. All right, benzyles, as I have given you in the first shot, the order is what you have to remember. Next, moving up, increasing order of the reactivity of this group. That would be what? So I can see there chlorine. So reactivity of isomeric halides with AgNO3. AgNO3 always will try to precipitate out as AgCl whenever you have Cl. So this Cl comes out, takes in the electrons and comes out as positive. I'm bringing out the electrons, positive. I'm bringing out the electron of chlorine, thereby positive. Bring out the electron of chlorine, thereby positive. So positive here on this carbon, you have a phenyl group and you have a phenyl group. Two phenyl groups attached with the benzene ring with a carbon pay positive. This is benzyl carbocations, which is very stable, I would say. So option 4 is the most stable here, I would say. There I got my answer, option C. Check out. Yeah, so otherwise you can just cross check also. This is one phenyl group here, and where else I can have a phenyl groups? Benzene, last positions you have phenyl. Option 3, देखो, option 3 you have phenyl group here, but phenyl के ऊपर, see, don't see this one. You can also check up with this. Option 3 में you have C6H5, carbon पे positive charge, which means you have a benzyl free radical, no doubt. But right side check karo, right side onto this, as you can see here, positive and then double bonded पे positive, that is your vinyl carbocation is unstable. The least stable vinyl carbocation, whenever formation, least stable. So least stable is option 3. Khatam ho gaya kahani. Fourth one is option, the most stable. Third is the least stable. Done with it, right? So that is how you can compare your answers as well. Right, next, moving on, question number 14, OH there given to you in the above reaction. The major product shown is this part, okay? So once the OH moves out, this attains a positive. As this attains a positive, it will be jumped on to this part, because thereby breaking the bond here, because whenever you have spiro compounds here, so this breaks down and then you will get a negative here, and the hydrogen here goes off as water molecule goes in, and then this will be attached. So thereby you will be getting a double bond here between those two rings. Now, which bond will migrate to form the above product? So obviously option Q will migrate faster, right? Because this is your 5-membered ring. 5-membered ring will always want to become a 6-membered ring, as in when you see a positive charge right above your 5-membered ring. So therefore option Q will be migrating. All right, next up, consider the following species when attached to the sp3 hydrocarbon, their leaving group ability in the nucleophilic substitution reactions. Whichever is a better leaving group, which means what? See, FClBrI, Br is a better leaving group. I is a better leaving group than bromine, and then Cl, then F, right? So iodine, the bigger electronegative groups, as we come down the group, the bigger electronegative groups, those are less electronegative, so they want to take up the electron, break down the bond easily and go out. And here also, as you can see here, sulfonyl groups, S double bond O and all these groups, these are all, so here you have S, 3 oxygens, S, 3 oxygens, definitely these are very bulky groups, very electronegative groups also. And electronegative groups, definitely, who can withdraw withdraw the electron easily and come out. I can see the CF3 here. Do you see that also? Yes. And CF3, this is a very bulky group with 3 fluorines dragging the electrons of the oxygen, thereby reducing the charge, reducing the negative charge here, right? And do I want the reducing the negative charge? Yes. So I want the best carboanion here, and also the best nucleophilic ability, substitution abilities is what I want. So number 1 is the best. Then comes with C6H5. Do you see here C6H5 with S with 3 oxygens? Then option 2. So first is much better, then 2. Then you have out of C6H5 O minus and CH3 this. Oxygen, when it donates the electron, C6H5, and then this is O minus. And then as it donates the electron here, electron goes in there. So then 4 is better. 1, 2, 4, and 3. That would be the best basis when I consider, right? So that would be the answer. You will be checking out for your basic character as well. Basic character, which means whoever can accept the H plus well. So you have so many negative groups there will accept the H plus very easily for option 1, then option 2, then 4 and 3. All right. Next, moving up with your next question, the correct order of the leaving abilities is leaving abilities. Who can better leave? That is what the question says. OH minus and H2O. So OH minus is a better leaving group. Yes, OH minus breaks down and leaves out very easily. H2O is a stable molecule as compared to that, right? Then OH minus and SH. So OH minus, no, SH will be leaving because as you can see, as I told you, FCl, I is a better leaving group. Similarly, OSSETEPO, O minus, S minus, OH minus, SH minus, SEH minus, all these oxygen, the bottom ones are better leaving groups because of their size. So here a comparison between OH minus and SH minus. SH minus is a better leaving group, not OH minus. So therefore, option B is wrong. And then you have here also, one second. Yeah, water molecule has got the best. Oh, 1 second. Sorry. Yeah, water molecule, OH minus and H2O. H2O is a better leaving group because of the best entropy. Water molecule, as and when formed, it will get removed. Best entropy, it gets removed. Okay, so that also option A is also wrong. And Cl minus and I minus. I minus is a better leaving group. I minus is a better leaving group. So option D is also wrong. Option C is right. See, because as you can see, O negative, negative puts in as a bond, bond breaks down, O minus. There is a beautiful resonance that is happening here. So resonance jahan par bhi hota hai, that is more stable. And then whichever becomes more stable, that moves out easily, right? So that is a better leaving ability that you get. Next, which of the following compound groups has the maximum leaving abilities? So as you can see, sulfur and your SO3, I can see there definitely that is my better leaving ability, option D first. Then you have 3 fluorines dragging them, so B then out of my OH minus and Cl minus, my option C will be the most leaving group, which is C, better leaving group. Then your A. OH minus is not that leaving group because it wants to stay back there. All right. Chlorine minus, being a bigger group, that would want to release out easily, that would want to come out easily, therefore a better leaving group. Next, moving on with your question number 3 there. As you can see here, 3 rates of reaction. The order of the reaction is being asked to us. Let us talk about the order of the reaction. Remove your bromine groups and then talk about the order. So bring out the electrons, just bring out the electrons wherever you have, wherever you have this chlorine, take out, or bromine. Bromine is taking out the electron, Br minus, carbon pe positive. Here also chlorine is taking out the electron, Cl minus, positive. Here chlorine is taking out the electron, Cl minus, and this is positive. So as you can see, bromine, this is my 3-degree carbocation, 3-degree carbocation on the bottom one, and the second one is my 2-degree carbocation, out of which 3 degrees are better. In 3 degrees, maybe which is more better is what you should see. 3 degrees, maybe you have bromine is a better leaving group. Therefore, R1 is the best, then R3, then R2. Right? 3 degrees, first you finish off with your 3 degrees, 3 degrees best hai, then uske baad you will be going up with your R2 there. So R1, R3, and R2. Do you see that? R1, R3, R2. Yeah, option C is your answer there. All right, next moving on. Which of the following compounds undergo even eliminations most readily? So even eliminations, again, you do the same thing. Even Br comes out positive. Okay, Br comes out positive on this. Iodine comes out positive. Iodine comes out positive. So whenever you have this, you watch for your 3 degrees or 2 degrees there. So here it's the option A 3 degree, option B 1 degree, option C 1 degree, and option D 3 degree. So you have 3 degrees at A and D. Bromine and iodine, D is a better leaving group. Iodine is a better leaving group. Then you have your bromine is a better leaving group. Then D, A ho gaya. Then coming up to C and B, both are 1 degree, right? Both are 1 degree. You have iodine, a better leaving group, which is C. Then your B, then bromine leaves in, right? So bigger group, electronegative group will move out easily. Better leaving group, that is, right? Next, which of the following will be most reactive for E1? So as you can see, propyl, groups, your cyclopropyl groups are very good groups, positive groups on this. So bromine brings out, see, this becomes positive. You have 2 cyclopropyl groups on the positive, carbon, which is your better leaving group, better, positive carbocation. So option, which of the following will be the most reactive? A, definitely A. Then you have, check out, Br goes out, this is positive here, and then Br goes out, this is positive, Br goes out, this is positive. Option D is 3 degree. Then you have option C as allyl. Okay, and then option B as your benzyl. So in your positive ones, in your carbocations, first always cyclopropyl, then you have 3 degree, which is option D, then you have benzyl, then you have allyl. So ADBC is my option here. So wherever you have carbocations forming, so check out with those carbocation stabilities, and then you will get your answer well. All right, next, moving up in the reaction given below, X is the major product. Okay, what will be your major product? That's what we have to see. 1 second, yeah. Please check out during the course of reaction, whatever I'm writing on with my colored pens and all, please observe that well. See, bromine goes out, thereby this carbon attains a positive charge. As the carbon attains a positive charge, whenever you see a 4-membered ring and then a positive, okay, see, it's a 4-membered ring, carbon and a positive, or a 5-membered ring and then a positive. Whenever you see such structures, 3-membered ring, okay, you see a 3-membered ring and then with a positive. Whenever you see such structures, there will be ring expansion. Ring expansion goes on there. So therefore, your 2 options are definitely eliminated out there itself. A and B are totally removed because they are 4-membered rings only. But when as I told you, have a 4-membered ring and then carbon ke upar positive, you have ring expansion going on there. And how do you expand your ring? So as you have this positive like this, it comes in, which means you have a 5-membered ring. Okay. You have now, it is turning out to be a 5-membered ring, and then is carbon, the whole, the blue carbon which I'm rounding off, you have 2 two carbons there, and then the positive charge will be shifted towards this position, right? The positive charge will be shifted towards the one next position to this. This is 1 and this is 2. Positive charge will be shifted to the position 1. That is my position 1 here, right? Now what is happening? Check out now. This carbocation so formed, the orange carbocation so formed is a 2 degree. But as you can see, one step behind, one step to the top of it, you can get a 3 degree carbocation by doing a methyl shift. So this carbon will take up the electron, becoming negative, and this positive. That negative carbon comes onto this positive. So which means you have a 5-membered ring. Here a carbon, there a carbon. All right, with a positive charge there. Now, as you get a positive charge, obviously the electron from here, hydrogen donates the electron there, thereby negative, and ye C+1 ke bahar, negative puts in as a bond, which means I have a 5-membered ring with a double bond, carbon and carbon. Option C is my answer there, right? So ring expansions is what you need to observe very carefully. If you want, you let me know. I can make some other video on the ring expansions and ring contractions also. All right. So whenever you have 4-membered ring, 5-membered ring, 3-membered ring, and then on to the top of the carbon, and then a positive, then ring expansion is possible. So A and B eliminated out. All right. Next. Moving on. So then we have a methyl shift happening there, because the most stable carbocation is what you have to fix it on. So 2 degree carbocation, and then you can see the 3 degree carbocation there. So 3 degree carbocation is the most stable. Therefore, if to form a 3 degree carbocation, I need to shift the methyl group. Methyl shift is what is observed, right? Then moving on, a relative rate of acid catalyzed dehydration of the following alcohols would be dehydration, which means you need to remove the OH minus, right? And then OH minus ho jayega, this pe positive, OH minus positive, OH minus positive, OH minus positive. Now, as you can see here, this carbon will be shifted. This is a 2 degree carbon, but then it will show a hydride shift. First option, it will show a hydride shift, and the positive charge comes here, right? Hydride shift, hydrogen will move to there, and then positive charge comes here. And here is a second option pe dekho, it is a positive charge, but still the positive charge will be undergoing the hydride shift. The positive charge comes onto the second position there, 2 degree pe. Okay, this is already a 3 degree, the best of all, I would say, right? And then phenyl group is there, definitely. Benzyl group is very, very stable group. So option 3 first, option 3 first. So option C and D to pehle se eliminate ho chuke hain. I got only 2 options left out now. Now option 3 ke baad, which is most stable, I can say, I would say question number 1 pe positive charge is hitting on to the 3 degree after the shift. So 1 is better. See, option number 3 may already carbocation is on the 3 degree with a phenyl ring. But question number 1 may, after the rearrangement, you are getting the same arrangement. So even though after the rearrangement, since you are getting the same arrangement of the 3 degree, that is better. Okay, then you have fourth option. Fourth option, 2 degree pe aa raha hai. 2 degree se you will come on to the 3 degree shift. So fourth is better, right? And then, so yahan pe do shift, single shift say you are getting a 3 degree, na? See, fourth option, with a single shift, you are getting a 3 degree. That is better, I would say, right? And then second option is the least of all, right? Because second option pe 2 shifts karna chahiye, only then you will get. So that is the least of all. So option A is my answer here. All right. Next, moving on with the next question. In the given reaction, C2H5OH, concentrated H2SO4, OH, oxygen, OH takes in the electron, goes out, carbon pe positive. Now, carbon pe positive aate hi, carbon will be shifted, right? So as you are shifting in the positive charge inside, because this part is your 3 degree, you will have a hydride shift going on. Then what happens is, then you have a CH3 on the top, you would get, and a positive here. Now, as you get a positive here, either the right carbon or or the left carbon will be donating the electron. Okay, so here as you can see, the hydrogen will be giving away the electron, minus ban jayega H pe positive. Now this H plus and OH minus water molecule ban jayega, bahar ho jayega, and benzene pe yahan pe negative and positive. Now that puts in as a bond, so which means you are going to get something like this. Option B is my answer there. All right. So that is how we need to check out very carefully. But please, whenever I'm drawing the things and all, please follow the drawings well. Otherwise, it will be very difficult. After the question, if you see, you would not understand anything. As I'm doing the transformations, please observe the transformations well. Now, concentrated H2SO4 and heat, again the same thing. OH, electron moves out, positive. Now, positive will be shifted. Okay, you have a carbon, carbon, two carbons. Here, a methyl shift is proceeded because we don't have hydrogen to go on with a hydride shift. So, electron will be taken out by carbon. C negative ban jayega. Is pe positive. This negative will be attacked here, which means you are getting carbon, single bond carbon with one already there and one the shifted. The star carbon is the shifted carbon. See, here is the shifted carbon. The star one I am showing you here. Star carbon is the shifted carbon there. And then is carbon pe positive dikh raha hai mujhe. And then you have carbon and then one carbon here. Right? Now, whenever you have such a group, then what is happening here? पॉजिटिव हियर ऑन दिस कार्बन 3 डिग्री कार्बन पे पॉजिटिव आ गया तो बगल वाला कार्बन को तो हेल्प करना चाहिए. नाउ विच कार्बन इज हेल्पिंग इट? सो विच कार्बन विल बी हेल्पिंग इट? द अदर कार्बन. सो दिस कार्बन, दिस फेलो इज अ 3 डिग्री कार्बन, राइट? 3 डिग्री कार्बन विल बी हेल्पिंग इट. सो यहां से हाइड्रोजन इलेक्ट्रॉन छोड़ेगा, ये माइनस बन जाएगा, ये H प्लस बन के बाहर. सो दिस नेगेटिव ड्रॉप्स इन एज ए बॉन्ड. सो कार्बन, डबल बॉन्ड कार्बन, you have two carbons there and here a carbon and then totally this carbon. So option C is my answer there. This is the same structure as what we have drawn, right? So be very careful who will give the electron, who will donate the electron, who has more, who has alpha hydrogens, and also who even after donating the electron will be stabilized with the positive charge or with the negative charge. That would be more stable. All right. Next, which of the following cannot undergo E2 reactions? Which cannot undergo is what is being asked to us. So always check up. You should have one hydrogen definitely onto it to go with your shift there. So this one is your 3 degree. Okay, is your 3 degree, but you don't have any. This is carbon. Carbon, carbon. Okay, this electron moves out and ये positive बन जाएगा, right? Positive shift हो जाएगा and then that becomes positive. So here also electron, option B पे check करो, option B पे electron is moving out and positive बन गया. Positive will be shifted there. Option A पे electron will be moving out, positive बन गया, positive will be shifted here. So which of them cannot undergo 3 degree? Readily available positive charge will not undergo 3 degree. Option C will not undergo, will stay there because it is SN1 reaction can happen there, one reaction at a time, because it's a very more stable carbocation that has been formed there, right? Then 2-bromopentane is heated with potassium ethoxide in ethanol. 2-bromopentane. 1, 2, 3, 4, 5. 2-bromo, second position पे bromo is heated with a potassium ethoxide. All right, which is my KOH के साथ कर रहे हैं. And then what happens? Electrons will be moving out. ETOH, right? See, ethoxide is nothing but alcoholic group पे hydrogen निकल गया. R OH group में hydrogen निकल के you are getting the metal there, and this is ethoxide, 2 carbons, ethoxide, potassium. Okay, so potassium is kalium. Okay, this is what we get, and इस पे positive आ गया. Now positive आते ही, this is my 2 degree carbon. 2 degree पे positive is good enough to go, no problem at all. The major product so obtained is the right side or the left side. Carbon will be donating the electron and moving out. So hydrogen electron donate करके carbon minus बन जाएगा. That minus as puts in. So carbon, 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 double bond carbon, carbon. That is what it is forming. Pent pentene is forming. So pentene. Now cis-pentene or trans-pentene? Trans-pentene is my answer there. That is more stable product which is obtained, because as you have seen in your geometrical isomerism, trans products are more stable products, right? So because of your net dipole moment, zero net dipole moment, as you can see there, but not in this compound definitely, but less dipole moments you will see in your trans products in this case. So therefore, this will be trans products will be your more stable products obtained. So option D, C and D both will be formed, but D is most. Next, in the following reaction, alcoholic KOH. Whenever you see alcoholic KOH, go with your elimination reactions. Definitely just, break out the bond, break out the electrons, move out. So this is chlorine minus and this way positive. Positive, same again here also, minus carbon pay positive. Chlorine bring out, positive carbon पे chlorine bring out, not this, one second. Option 4 में देखो, where is my chlorine there? In option 4, here is my chlorine, bring out the electron, is a positive. Now, the positive here is your 1 degree. This is your 3 degree. Which of the following reaction selectively can be observed? I would say option C is the best here. Option C. Why best hai? Because that is directly 3 degree. Direct 3 degree. See, option A can be brought to 3 degree here by doing a hydride shift. Okay, by doing a hydride shift, it can be brought. Whereas option B is again a 3 degree, definitely. Okay, but you have more number of alpha hydrogens available on option C. Option C, more number of alpha hydrogens available. So therefore, that will be even more better to go up with. So option C is better than B. Then you have D, then you have A, right? So that is how you need to check up with which is more stable and all. Please check according to the stability. All right. So for here, for this question, option C is your answer then. Next, 13th one, C, B, D, A. C, B, D, and A will be your answer here. In case options are in case your order is being asked you, that would be the answer. Next, moving on, the most probable product in the following reactions, excess KOH is given to us. Excess KOH. What happens in the case of excess KOH? First, let us remove one Br minus होके निकल गया, कार्बन पे पॉजिटिव आ गया. Now कार्बन पे पॉजिटिव आते ही what happens after, because it is excess ethanol, here also you have one hydrogen also, right? So hydrogen from here or hydrogen from there, which hydrogen will be releasing the electron and coming out? Definitely my bromine ke saath jo hydrogen hai, bromine is electronegative, draws the electron, it cannot stay there for a longer time also, so therefore it want to come out. So this will give away the electron, comes in, so ye negative ban jayega, so negative drops in as a bond. So therefore, what am I going to get? I get one double bond there, and after that I will have one more removal. Excess KOH is thrown to us, so after that I will have one more removal, which means I will get two double bonds. So two double bonds, either option B or option C. Two double bonds right adjacent to each other cannot be possible. Option D and option A, I'm removing it. Okay, and I'm now left out with only my option B and C. B and C may, B is very unstable, C is stable, because two adjacently placed double bonds cannot be possible easily. All right, next, moving on. Which of the following will undergo fastest elimination reaction with alcoholic KOH? Fastest elimination, I would say, cis and trans may. Trans is more stable, so cis will be undergoing faster. Option A and B may, A is more faster. Okay, and eliminations, as you can see here, bromine, and option C and D also, let us check. Bromine here is पे positive आ गया. Bromine bring out positive aa gaya. So you have methyl groups very far apart from each other. So when you have a far group of other methyl groups, that methyl groups, yes, that will definitely support, but not to a greater extent. So when you have to talk about the greater extent, it has to be the adjacent methyl groups. And adjacent methyl groups in option A and B we can find. In that also, A and B may, B is trans, more stable. So option A is my answer. Cis, unstable. Under unstable will undergo fastest elimination reactions. React ho raha hai, matlab you are unstable. If you are unstable only, then you will react faster, right? So that is how we will go. Next, moving up, major products obtained. You have bromine, see, 1, 2, 3 with Br on the top and C here, and C here. Okay, this is my question. So what should we do now? Methyl, okay. Okay, methyl, okay, MEO minus and K plus, MEO minus and K plus. And then Br electron लेके negative बन जाएगा, carbon पे positive आ गया. Now what to do? So now the hydrogen has to get removed because carbon पे positive आते ही, the green one, देखो, I'm under rounding of the carbon on positive. So that carbon has to be supported with another electron, and that electron has to be coming from the adjacent carbon, either from the right side of it or from the left side of it. But here in this case, left side I would say, because left side has got hydrogen and moreover it's a 3 degree. This fellow, this blue one, electron छोड़ के हाइड्रोजन इलेक्ट्रॉन छोड़ के C minus बन जाएगा. Now this fellow becomes H plus and moves out, and then negative drops in as a bond. So carbon, double bond carbon, right and bottom, right and bottom. This is what it is formed. So which means you are having carbon, double bond carbon like this, right? So option A. See, this one is the compound forming. Do you see any other thing there? Yes, I can see option B also. ऑप्शन ए एंड बी दोनों भी. ऑप्शन सी तो है ही नहीं यहाँ पे. ऑप्शन सी इज नॉट, oh sorry, ऑप्शन सी ऑल्सो इज देयर. Oh no, not option B, I mean to say option A and C I can see the same. A and C, this one and this one, but I'm just rounding off. Okay, yeah, these two I can see definitely. Now we need to check up methyl, 3 methyl groups with CO. O with 3 methyl groups, O minus ban gaya. Now this is a bulky base, right? So bulky base cannot come in there, right? So if you have a bulky base, then what is that option that we get there? So here, as you can see, same thing again, carbon, 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 and bromine there, niche carbon, carbon. Yeah. So this is my question here. Now I have a bulky base. Bromine goes out, right? Bromine will be going out, taking the electron, minus बन के बाहर. So carbon पे positive. So carbon पे positive आते ही, what happens? This O minus will want to come here and attack, right? Because oxygen पे negative charge, and all these 3 carbons are supporting this carbon and thereby increasing this negative charge of oxygen. When you have increased negative charge of oxygen, it is very unstable and it wants immediately to get stabilized there, right? So therefore it really wants a H plus. So H plus immediately gives in there and H plus ban ke bahar. Now this will go out, and then what is that left out part? You have 3 methyl groups with your O minus and so one second. So you have 3 methyl groups and OH now. That would not be acting as a base there. Yes, that would be acting as a base. Carbon, carbon, carbon. This is OK, right? So here oxygen and K, OK goes out, right? And then carbon पे positive आ गया. Now carbon पे positive आते ही negative पे attack करेगा. That is option A. Option A is what is getting formed there, right? So that is how we will check up with. So not A. I think it is C. This part. Yeah. Sorry, bacha. Yeah. So this is what is formed, not two hydrogens. This is what we are getting up with, because we have the carbon pair positive charge attacking onto these compounds, thereby you are getting those compounds. So in option A and C, so blue ones, the first ones are both right, then not this. So definitely option, this part, so option C is my answer there. Next, moving on. Even CB reaction is given by which of the following compounds? So what do you mean by even CB reaction? We'll go up with your even CB means elimination one conjugate base. So which conjugate base is more reactive, very stable? That's what let us check up. So you have two chlorine groups there. Once the chlorine group is removed, carbon pe negative mil jayega. And then you have three fluorines which are dragging the electrons towards them more efficiently. I said very good. This is good. Stable negative ion this is forming. And bromine takes out the electron for option B. They check out carbon पे positive आते हैं. You have बगल में nitro group NO2 group, right? Two oxygens and one nitrogen. Nitrogen पे positive आएगा ना. See, this is N double bond O minus, nitrogen पे positive, and nitrogen पे positive will drag the electron towards more efficiently. Very good. Option B is also done. Then all of these, right? Check out with this as well, right? Option C पे भी देखो, C double bond O CH3, that will break down CH3, C double bond O, and this part will become carbon dioxide. Decarboxylation reaction happens, electron will be taken out. So is carbon पे positive आते ही you have this nitro group and all there. So definitely you can go with all of 1 and 2 आ गया, तो all of these बच्चा you can go very well on that. It is all of that above. Next, moving on, state the formula representing the major product of the following reactions. ETONA, ethyl ONA with hydroxide group, both are there. So what is happening there on your question number 17? Bromine. So first remove your bromine there from this position, Br. Let me use another pen. Right, yeah. So bromine takes out the electron, bromine electron ले लिया, तो this carbon पे positive आ गया. Positive आते ही the other carbon should be helping it. So this is the carbon which will try to help. Right side में carbon जो है, और I would color change green. Yeah, this green carbon will help it, thereby giving the hydrogen electrons. So hydrogen H plus बन के बाहर हो गया, and इस carbon पे negative. उस carbon negative आते ही you put in as a bond, which means carbon double bond carbon. Then you have hydrogen CH3. Then you have CH3 C2H5. So which is the one? Option 1. Option 1 is my answer there. Also, there is some stereochemistry also involved here. So let us also focus on that stereochemistry there. You have one CH3 and C2H5 there, right? So when this electron is being donated there, ethyl, this will be your bulky group coming. It's a lighter group coming in. You can go up with your syn addition there, and then dono bhi on the top. See, it can be like option A and C, both are same, right? H and CH3 remains the same, but your stereochemistry inverts. So C2H5 and CH3, because as you're moving out and the other element is coming in there, so as you put in the bond, the bonds will interchange there, so thereby forming C2H5 on the top and CH3 on the bottom. That is how you get. So option C is my answer. A and C both hoga, but C zyada hoga. Select the formula representation. Major product, that is what said. Major will be this. Also go by the same thing. No, you go by your geometric isomers also. As you go by the geometric isomers, what do you get? Where are your bulky groups? You can check out, right? You can go on with the bulky groups here and here. That will be your onto the same side. That will be antagonon or jusamin. The same side is jusamin. Antagonon is this. So trans, that would be more stable, right? So option C is more stable structure. I can go. So stereochemistry you want to go up with also, because there's a combination of the topics that we are going to discuss. So be hitting up with all the topics together on it, right? So next, So this is how we can go up with, I think, then the nucleophilicity, then we will be going up with your next session there. All right. So this is about stability order, talking about stable carbocations, carbanions, all these kind of stuff. So please keep doing the questions on your own, and then any doubts onto it, you will get back to me on that. All right. So happy learning on your holidays, on your vacations. Happy learning, bache. Take care.